Good morning students. Today I am going to start a new chapter, that is chapter number 11 in your book. The name of the chapter is Programming Guidelines and Case Studies. The topic for discussion today is the Introduction to Software Development Life Cycle, in short SDLC. Software development is the field of software engineering that deals with design, development and maintenance of software and its applications. One software application may consist of millions of lines of code. We call those lines of code which are necessary to build a software application as a program. You will be astonished to know that a program is written once but read 100 times more and goes through many changes during its lifetime. Hence, it is very important to follow some systematic approaches and standard guidelines while programming. In this chapter, we will discuss about the software development life cycle, features of a good program, and standard programming guidelines. So let's start with the software development life cycle, in short SDLC. Software development life cycle is a systematic way of developing and maintaining systems. There are various phases of a software development life cycle, like the system requirement specification, system design, coding, testing, implementation, and maintenance. All these phases are very important in a software development life cycle. Any software that is being developed will follow these phases. Now there are different types of models that implement the software development life cycle. The popular ones are the waterfall model, iterative waterfall model, prototype model, and the evolutionary model. Waterfall was the first classical and theoretical model and resembles a cascade of waterfall, as all the phases flow in sequential manner starting from system requirement specification till the maintenance. That means in a waterfall model that implements the software development life cycle, the first phase will be the system requirement specification, followed by the system design, then the coding phase, then testing phase, then the implementation phase, and finally the maintenance phase. And waterfall model was the first classical and theoretical model that was used to design and develop a software application using these phases. Other popular models such as the prototype model and the evolutionary model, they are formulated on the basis of the waterfall model. That's why prototype model and the evolutionary models are known as the derivatives of waterfall model. So these are the 6 phases of a software development life cycle model, be it a waterfall model or an iterative waterfall model or an evolutionary model. Let's start with the first phase of an SDLC model, which is the system requirement specification, SRS in short. The system requirement specification is the first stage of a software development life cycle, and it provides a clear picture of the physical system. In this first phase, preliminary survey of the system is done to identify the scope of the work, followed by detailed and in-depth study to identify the user's requirement. A system proposal is placed before the user. The proposed system contains the details of the present system and the suggestions to overcome the limitations of the present system as per the user's requirements. In short, system study phase passes through problem identification, project initiation, background analysis, and findings of the existing system. And on the basis of the outcome of the initial study, the feasibility study is done. Now say for example, you are asked to develop a software application for a client. So the very first thing that you are going to prepare is an SRS document through which you are going to put down every idea on a piece of paper to cover all the details pertaining to your client's requirements. An SRS document describes what a client wants and what developers will provide. So the software requirements specification document or the SRS document lists all the necessary requirements for the development of a software application. So it is a form of written agreement between you as a contractor who is undertaking the project and then your clients. The major components of the feasibility study are meeting the user's requirements and the effective use of the resources. The user here refers to your client. The main goal of the feasibility study is not to solve the problem but to achieve the scope of the work. In this process of feasibility study, the cost-benefit analysis is done with greater accuracy. So it is during this feasibility study phase where you have to speculate the estimated cost of the project. That will include costs on various factors such as the manpower resources, the technical requirements such as the hardware and the software, the platform to be used, etc. And whether you will be earning any benefits out of doing that project work for the client. So to put it simply, that whole process of cost-benefit analysis is done with greater accuracy during the feasibility study phase. After the feasibility study comes the system analysis. Now just like the feasibility study, the system analysis is also a part of the system requirement specification or the SRS. During the process of system analysis, the data is collected from the existing resources, decision points, and various transactions handled by the present system. The present system can be the manual system which is being implemented by your client. Now say if you are asked to modify the present system, which is the manual work system, into a computerized system, that will involve the development of a software application to perform all the activities of the manual work. It is important to collect data from them and make decision points, conduct interviews, on-site observation, and questionnaire wherever required for an in-depth system analysis. And at the end, all the requirements are analyzed and documented in the form of detailed data flow diagrams, entity relationship model, data dictionary, the logical data structures, and the miniature specifications. Now just after the first phase of the software development lifecycle model, which is the software requirement specification, the next phase is the system design phase. System designing is the most crucial phase in the development of a system. Normally, the design comprises of two stages, the preliminary design and the detailed design. In the preliminary design, the features of the new system are specified. The cost of implementing these features and the resultant benefits are estimated. If the project is still considered to be feasible, we then move to the detailed design stage. Say for example, you as a contractor, If you undertake a project to develop a software application for a client who wishes to change his manual system into a computerized system, you have to add some features into the new system, and introducing those features will incur some cost, such as the labor cost, the technical cost, and the manpower resources. And if you see that there is a benefit coming out from the expenses that you have incurred, you may consider the project to be feasible. And then you can move to the detailed design stage. In the detailed design stage, the computer-oriented work begins. Here the design of the system becomes more structured. The structural design is a blueprint of the solution to a given problem. In this stage, the input, output, and the processing specifications are elaborated in detail. Here the operating system, the programming language, and the hardware in which the new system are developed and executed are decided. So obviously, whenever you design and develop a software application, that software application has to run on a particular platform. The operating system on which that particular software application should run is decided. Examples of such operating system can be Windows, Linux, or Mac. The programming language required to develop that software application is also being decided. The examples of programming languages can be Java, PHP, C#, etc. And then, in addition to that, the hardware requirement is also decided. The examples of hardware requirements can be the processor speed, RAM memory, the hard disk space, etc. And once the platform is being decided, the data flow diagrams, the entity relationship models are used to design the system. Now once the detailed design is prepared, that detailed design is essentially required to be coded. And this brings us to the next phase of the software development lifecycle model, which is the coding phase. Hence, coding is an important stage where the functions and procedures are programmed into control specifications with the help of a suitable computer language like Java. So the coding step requires the detailed design of the system to be divided into a group of modules, and we call those individual modules as functions and procedures. And these functions and procedures are programmed and then integrated together to build the entire software application. And that can be done using any suitable computer programming language such as Java, C#, PHP, Python, etc. The programs coordinate the data movements and control the entire process in a system. After the coding phase, the next phase is the testing phase and debugging. The testing phase is done to eliminate some bugs or errors that are being found in the coding phase. And if any such bugs or errors are found, they need to be rectified or removed during the debugging phase. So in this testing and debugging phase, a test run of the system is done to eliminate bugs or errors before actual implementation of the new system is put to operations. That means before the software application is being implemented and put into operations, it is necessary to test that system and to eliminate any bugs or errors if there exist in that system. And once the system is free from any bugs or errors, it can be easily implemented and put into operations. So testing and debugging is an important phase of a successful system. As a result, after codification, a test plan should be developed and run on a given set of test data. The output of the test run should match the expected results. Now say for example, if you are a developer who is developing the software application, you should be able to predetermine the expected results that will be coming out of the system. And the system that you have developed after testing produces the expected results, then the test run was a success and it has matched the expected results. Now testing is done at the unit level as well as the system level. The unit test is carried out at the program level. All the programs must be individually tested. Now, as I have already explained, that the system that you have designed has been grouped into different modules, and each individual modules have been codified using a particular programming language in the form of functions and procedures. And we call those functions and procedures as an individual unit in a program. So the testing of each and every unit in a program should be carried out. Testing such as the white box testing, black box testing, the boundary level testing and the stress testing are the commonly used in unit level testing. The white box testing ensures testing of all the logics and execution parts in the programs. The black box testing is done with random input data whose output is known. Since only the developer is familiar with the logics and the execution parts in a program, so the white box testing is usually done by the developer. But testing the system using random input data can be done by any user. So black box testing is usually done by the end users and not by the developers. The end users can be the clients who shall be testing that software application, whether it is meeting their demands or not. The next type of testing is the boundary value testing. Now the boundary value testing, as its name suggests, here the programs are tested with extreme limits of the input values. So here the random input data in the boundary ranges are fed into the system for testing. And if it produces the expected results, then the boundary value testing was a success. The next type of testing is the stress testing. So in the case of stress testing, the robustness of the program is tested by giving some spurious or fake values. And if the system that you have developed does not respond to spurious or fake values, then we can say that the system is robust and strong after the stress testing. Now any undesirable happening with the testing process must be noted and then debugged. That means if we find any undesirable results while testing the system, those bugs and errors should be rectified in the debugging process. The system test is done after carrying out the unit test for each of the programs of the system. So once the white box testing, black box testing, the boundary value testing and the stress testing is done at the unit level, then the system test is done after carrying out the unit test for each of the programs of the system. At this stage, the test is done on the realistic data. The complete system is executed on the actual data. So now it is this system testing phase where the project is being shifted to the actual testing site, that is on the client's desk. And since the clients are the end users they shall be testing the system with the actual data that they possess. At each stage of the execution, the results or the output of the system is analyzed. During the system testing, if the outputs are not matching with the expected output, the errors in the particular programs are identified, and then they are fixed and further tested for the expected output. Now, system testing commonly consists of three kinds of testing. Those are the alpha level testing, the beta level testing, and the acceptance level testing. The developer performs the alpha level testing. The potential customers or the end users perform the beta level testing. Since it is the end user or the customers who shall decide whether to accept or reject the software, therefore the acceptance level testing is performed by the customer to accept or reject the software. If the software meets the client's demands, or if the software meets the end users or the customer's demands, then the end user or the customer shall accept the software, or else if the software does not meet the end user's demands, he shall reject the software. Now, just after the testing phase, the next phase is the implementation phase. Now, once the end user has accepted the new system after testing, then the implementation phase begins. Now, implementation is the stage of a project where the system is put into practice in a realistic environment, that is on the client side. During this phase, all the programs of the system are loaded onto the server and the client machines. The user and the software maintenance level also starts in this phase. So once the project or the software application is being implemented at the client side, then the end users are trained on the computerized system. The manual working has to shift from the manual into the computerized working. Commonly, the strategies followed for running the newly developed system are the parallel run and the pilot run. In case of parallel run, computerized as well as manual systems are executed in parallel. This strategy is helpful because manual results can be compared with the results of the computerized system. Now, since the computerized system and the manual systems are executed in parallel, so the failure of the computerized system at an early stage does not affect the working of the organization. This is because even if the computerized system fails, the records still exist in the manual systems. But in the case of pilot run, the new system is installed in parts. Some part of the new system is installed first and executed for considerable time period. When the results are found satisfactory, only then the other parts are implemented. This strategy builds the confidence and the errors are traced easily. Then the last phase of the software development lifecycle model is the maintenance phase. This phase starts just after the implementation phase. So once the software is being implemented at the client side, the maintenance of software is also one of the important factors of a software development lifecycle. And it is this maintenance phase which generates the maximum revenue in the software industries. The maintenance is necessary to eliminate the errors in the system during its lifetime and tune the system to the changing working environment and government policies. That means with the changing working environment and the new government policies, it may be necessary to add new features into the existing system as well as modify parts of the system. So we have to tune the system to the changing demands. and this puts maintenance as a necessary phase in the life cycle of the software development. And so with this I end my presentation here. So that's all for today.